In the previous video, it was quite easy to know where to add the H and form the carbocation because that initial alkene that was symmetric, so we didn't have to make a decision on where to add that first H. But that's not always the case, and that's what the Markovnikov rule is about. When we have an unsymmetrical alkene, we can have two possible products. If you see, we have here propene. It's a quite simple molecule. This alkene, which is electron rich, will go and grab the H. But now you have two possibilities because that H could end up in position 2, giving me that carbocation, or it could end up in position 1 and give me that carbocation right there. Now, with what you know about stability of a carbocation, you can make an assessment of which one of these two is probably going to happen. Remember that secondary carbocations are more stable than primary carbocations, and that's why this product is not going to happen. Now, the Cl that left on the first step can come back in and attack, and that's how we get this product right here, the 2-chloropropane, as the only product, because this first one right here, it will not happen, because for it to happen, it will have to go through a primary carbocation, and remember, primary carbocations are not likely to happen. And so that's exactly what the Markovnikov rule tells us. It says that when we are adding an HH to an unsymmetrical alkene, the H atom will connect to the less substituted carbon atom, and that will give us the more substituted carbocation. So let's look at it in detail. So here we have the same alkene, the two possibilities, right? And this here will give us the primary carbocation, here will give us the secondary carbocation. So the H will always add to the less substituted carbon, in this case is this one right here on the edge, because that will give us the most stable carbocation, and now the Cl can come back and attack there and give us this product. This product, we will say that it's the Markovnikov product. If you remember the Hammond postulate, it tells us that the product that will form is the more stable because it's the one that will have a lower activation energy, right? So the reaction that will happen faster is this one right here, because it will result in the more stable carbocation, which is the one that is more likely to happen. So now we can talk about the stereochemistry of an electrophilic addition. We've established that when we have an alkene that is unsymmetrical, this will come and attack here, and that will leave. And so you can pause the video here and decide where do you think that the H is going to end up. Is the H going to end up here, or is the H going to end up here? The H will end up in this position, and the plus will be right there because this is the less substituted carbon, so that's where the H is going to be. And now the Cl has to come and attack, right? But remember, this is a carbocation, so carbocations are sp2 hybridized, which means that the Cl could come and attack either from the top or from the bottom, and that's how we get a racemic mixture of two compounds, A and B. Right, so here, this will come, the Cl will leave, we will form that carbocation and that carbocation, and now the Cl can either come from the top or from the bottom. Right here. So if the Cl comes from the top, it will give us a syn addition because the H and the Cl came from the same side. But if the Cl comes from the bottom, it will give us an anti-addition because they will come from opposite sides. In this case, it doesn't matter because in here we have two H's and they are identical, so that doesn't matter. But for more complex reactions, it will matter if we add the H and the Cl from the same side or from opposite sides. And here you have a summary of hydrohalogenation reactions. Remember that the mechanism involves two steps. In the first one, that is the rate determining one, the carbocation is going to form. And then in the second one, the Cl, the Br will come and attack. And because we go through a carbocation, a rearrangement could occur for the Regio selectivity, which means where is the H and where is the Cl or the Br or even the iodine going to go. We need to look into the Markovnikov rules. So the Markovnikov rule tells us that the H is going to go to the less substituted carbon and that the Cl, the Br, or whatever is the group that we are adding will end up in the more substituted position. And in terms of stereochemistry, because we go through a carbocation, the addition could come from the top or from the bottom, meaning that we could have syn or anti-addition.